Okay. Our next speaker is Thomas Schmitz from Bonn University, who will talk about producing different forms of output from XML via context.
Thank you very much. Good morning, everybody. I will be showing today
You need to switch it on, I guess.
Okay.
Oh, yes. No. That.
Okay, thank you. Let's see if I get it. Yeah, that sounds better. Okay, so what I'm going to be showing you today is the actual workflow that I use every week during our teaching terms. I teach ancient Greek at Bonn University. My department, Robin has just mentioned, is just across the street, the modernist building you can see when you step outside here. And I have to give, and I enjoy very much giving, a lecture course of about 90 minutes every week of the term. And the lecture course this year, let's see if I can, this works. Nope. Oh yeah, there it is. So the lecture course this term, which ended just yesterday, was on the Athenian poet Aeschylus. I've been teaching in Bonn now for 20 years. You can see I'm not that young anymore, and over the time I have changed and adapted my workflow for this lecture course. About 18 years ago I began using TeX for various tasks. I switched from LaTeX to context a couple of years ago. At first I used context to produce my own lecture notes, then I used it to produce the slides. And then I discovered that I found it extremely helpful to have the text of the slides and my own notes in the same source document. And I looked for ways to produce all the materials from one and only one source document. I experimented with different formats, and in the end I settled for XML as a source. Why? I don't want to become dogmatic or generalizing here. I just want to point out that for my purpose, XML presents a number of important advantages. It is easy to reuse in other programs. If, for example, I want to take a part of my lecture for an article or a book, that's easier in XML than it would be in a TeX document. And as we will see, it allows output in different formats because of the way it is processed in context. Maybe it's best if I just show you what I mean when I say different formats. First and foremost, of course, it's the slides that I show in my lectures. That is something I want to produce from my source document. They should help students understand and master the subject, and they contain different forms of material, such as pictures. Here you see a beautiful picture of a papyrus fragment, an ancient papyrus, or they contain tables. This is one table that shows the content and the dates of individual classes for the entire term. And of course, most of my slides contain text and translations. I teach a philology after all, so this is the basic setup. You see text, translation with markings and so on. The slides themselves have been produced with the context module Simple Slides that Aditya Mahajan and myself wrote a couple of years ago. Aditya, I should say, contributed most of the clever code. I applied it and thought of different appealing visual styles that I believe would good look for presentations. Of course, the code for this module, the several different styles, everything is publicly available. You can download it from contextgarden.net. It is absolutely not as powerful and versatile as the famous LaTeX Beamer class, but it offers a number of, as I find, interesting and nice styles for slides and makes it easy to produce such presentations. I'd always made these slides available to my students simply by uploading them to my departmental website, and then a couple of years ago the students asked me to provide the slides in a format that was easier for them to handle and to reuse. So that is the format that I produce on an A4 sheet. The left side has a very simplified and scaled down version of the slides, minus all the decorations, the backgrounds, the fancy effects, but still keeping all the important elements, the text, the table, the images, and so on and so forth. The right column is blank, so students can take notes on these sheets that relate directly to the slides, that help them to relate the material or their notes to what they've been seeing in the course. This wasn't my idea, I should say. It was the students themselves who came up with this format, and I find it excellent. It's a very efficient use. Finally, I also generate handouts from my XML source when I give an individual lecture at a conference or as an invited speaker. These handouts are the way they usually look in the humanities, which means you have text passages, you have translations, and in the end you have a bibliography. For a lecture course, it's only the bibliography, as you see here. And as you may be able to see, it's a bit small, I know. I'm a huge fan of numbered bibliographical styles because they make it so much easier and faster to refer to items on a list during my talk or during my lecture. Saying this is book number 77 is of course much faster than describing this appeared in 1989 and so on. So this is, if you want, the client-facing side of my business. But of course, as important is the material that I produce for myself, that is the notes for my lectures. This is a no-nonsense, very basic format for my manuscript. The locations where I have to change slides are simply indicated by red numbers that you can see here in brackets. The slides themselves are not rendered, so I just know now I have to change slide because this is where slide 6 and 7 is coming up. This format is very readable on a small device, such as a tablet or even a huge phone, and it has the benefit that the amount of text on these index cards is pretty standardized, so I know exactly how many pages I will need to fill a 45-minute presentation. I know I need about 20 to 22 of these index cards that will exactly fill a 45-minute presentation, so it helps me preparing. In general, however, I prefer to have a manuscript with the slides on my tablet when I give a lecture in exactly the form, the slides in exactly the form that the students see on the big screen, which of course is behind me as it is here. So I have this format that has the slide on top and then the text of the lecture below that. All these different formats and outputs are produced from one common source file. Let's call it lecture.xml. This file is then compiled with context. There won't be time today to go into all the details, but I want to just point out a few features of how to process XML with context. Like most things in context, you just saw some examples in Raban's talk. This is done via setups. You collect all of these setups in an environment file. You see here the beginning of such an environment file. Just a few remarks. The setups are collected in start-stop pairs. That's what you see in line 1 and line 5, start, stop. Line 2 is important. It means drop everything. Do not typeset any element unless it is explicitly mentioned in the following list and has its proper setup. If this line is not there, context will use some heuristics to typeset at least the text of every XML element, but I wanted to drop everything unless I tell it to produce something from it. And then follows a list of elements hierarchical from the root of the XML file down to all the other elements. After collecting these elements that you want processed, you create setups for every single individual one. They all live in the XML namespace. And just to give you an idea of what these setups look like, I show here some examples, some very silly and easy examples for an element presentation. The easiest command is in line 2, XML flush. It takes the content of the current element, in this case the element presentation, and puts this content into the text stream, where the text will be typeset, sub-elements will be processed according to their own proper rules that we define, and so on and so forth. After every element that's in line 3, you see, context will insert a paragraph break. Of course, you can apply all the usual context commands to the content of the element. In line 7, we flush the content of the element inside a command that will apply the color red to all text, and it inserts at the end a page break at the end of these elements. No, I shouldn't. These are choices. You have to choose between them. You can't have them all in your own file, of course. You're right. Yes, they shouldn't. So in this case, presentation would put a page break and it would typeset everything in red. If the element presentation has an attribute title, this attribute can be retrieved and typeset with the command XML at, that's in line 12. And then we use this attribute title to produce a section with a title. We flush the content within this section, and we're done with it. If you want to process individual elements via Lua, you know that Context now has the full power of Lua at its disposal, and as we will see, some things are easier to do in Lua than they are in Tesh. You need to create a setup in which this is made explicit, as you see here in the upper part of the slide. So you say you have an XML setup that says XML function, which means you just hand this content to a Lua function. This function takes as its argument the content T of the current element and passes it on to Lua in the form of a Lua table. That's why we call it T. This allows us certain shortcuts, as we will see. We then define this Lua function sml.functions.framed in this case. Within this Lua function, we have access to both all Lua commands and to context commands, and this makes some tasks somewhat easier. I show, again, a very silly example just to give you an idea. In real life, of course, everything is messier and more complex. First, we define a numerical value scale factor that depends on the context mode that we're in. If we're in mode print, well, slides are typeset with reduced width, you just saw an example, this value will be set to 0.5. In all other modes, it will be set to 1, as you can see in lines 2 to 6. We then use this value, this scale value in line 9. We multiply the value of the attribute width of our XML element framed. This is what the shortcut t.add.width refers to. First with a scale factor, and then with the dimension text width. The result will be that this frame will be spread across the entire page. It will have the text width in other modes, and in print mode, it will be multiplied by 0.5, so it will spread across half the page. Within this frame, we then flush the content of our element. Line 10 shows one difficulty or one little thing that you have to do from time to time. Some context commands need to be finished before the typesetting can begin, and this is why we need this somewhat clunky function and then end here in line 10, which doesn't look very nice, but from time to time you will need it. If you want to learn more about these details, you can look at the manual CLD, which is part of the context distribution. This then, in short, is the way Context produces XML. Let us now look at the setups that I use to derive different forms of output from my XML source. And I begin with a schematic representation of my workflow. In order to compile the XML file, we need a context style file, style.tag, which is coupled with a Lua file, style.lua, where the Lua commands are defined, as we've just seen. Some things are easier, at least I find them easier, when you have the power of a programming language such as Lua, rather than doing everything in pure Tesh, even though I know that some Tesh wizard would be absolutely capable of doing everything in Tesh. Over the years, the code has become rather complex, so I won't try to show you the details, but only some main lines. And I hope you will see why I've chosen this workflow and what advantages it offers. Let us begin by having a brief look at the main structure of my XML file. The text for the entire lecture course is in this one XML file, which will grow to around 30,000 lines over the course of a term. The structure is very simple. We have a root element, lecture, which consists of a number of individual presentations. Each one of them, as you can see in lines 2, 9, and 16, has a title and has content. And the content consists of the text, this is my own notes, and the slides that will be shown on the screen, as you see here. When I compile, it's obviously efficient to have all chapters, all the presentations in one single document, because it makes it easy to create cross-references, makes it easy to create a bibliography with consistent numbering that will not change over the course of these lectures. However, when I want to compile slides for an individual lecture, I don't want all slides included in the resulting PDF file, which would be huge, including all the images and so on. I just want the slides for my current lecture. That's why every individual lecture has a date tag, as you see here. I have used or abused something that Robin has already mentioned, which is a feature of context called modes. It provides a means for conditional typesetting. With modes, you can exclude or include parts of your source during the typesetting process. This is where the date tag of the individual lectures comes in handy. When you want to process XML with context, you define in your style rules for every single XML element. We've seen that. In our case, that would be the element with the name presentation. This is what line 1 does. And then we set a mode. The following code will only be seen by context when it is in mode presentation. Inside this mode, we nest another mode. This time, the mode is set from the date tag of the presentation. That means context will only typeset a presentation element if its date tag is equal to the mode value that we pass to it. How do we achieve this? You pass these modes to context on the command line when you compile your document. So this is what mode presentation, we want to be in presentation mode, and then 230516 does. Context will now only produce or will only look at the XML code of the presentation with the date tag 230516 when it's in presentation mode. In other modes, for example, to produce my lecture notes as index cards or to produce a handout, it will process the entire presentations, everything in the document. Let's have another look at this conditional processing. Here's the context code that will process the element slide. Here it is. When we're processing in presentation mode, which we do from line 2 on, context will pass the entire content of this element to a Lua function presentation slide, where we take care of the elements, we include pictures, we typeset tables and text and so on. However, when we're in the mode cards and want to produce our index cards, something else happens, and that is what happens in lines 5 to 8. Context in this case will, whenever it sees a slide, only increase a special counter for the slides by 1 and typeset the result on its own line. We've seen this, the result, a couple of minutes ago. This way, I will never have to worry about forgetting a slide in my manuscript, something we've all seen happening. The presenter is talking about the next slide and the older slide is sitting there and he doesn't realize or she doesn't realize. In my case, I always have these red numbers that remind me you have to change the slide. When we're in combined mode, the content of the element is passed on to a Lua function that is defined in style.lua. We have seen the general outlines of how such Lua functions work. Here we find another example of things that I find easier to do in Lua than in Tech. As we've seen, context transforms every XML element into a Lua table, and we pass this table T as an object to the Lua function combined slide. That is number 4, line number 4 here. We retrieve the current tag, which is the date of the current presentation. That's what we do in line 6. We know that the presentation is the grandparent of the slide. Remember the structure was presentation, content, and then slide. So we have to go 2 levels, we have to move 2 levels up to find this tag. This information will be used in line 12. The slides for every individual presentation are stored as PDFs in a subdirectory presentations and are named after the current date. So the slides for today's presentation would be in a document called 230715.pdf. Line 12 constructs this file name and retrieves it as an object of the context macro external figure. Line 13 retrieves from this PDF file the page, one page, only page I from this PDF file, and since the counter of I will be increased every time this function is called, that's what we do in line 1, it will retrieve all pages in ascending order every time this macro is called. Before the current slide, context inserts a page break. That's what line 8 does. This way, the current slide will always be on top of a new page above the text that explains this slide. And since it retrieves the slide from the actual presentation that is shown on the screen, it will look exactly the same as what the students see on the screen. This then is the general mechanism to produce different forms of output from a single XML file. We use context modes to apply different setups to XML elements. Depending on which mode we're in, the slides or text for nodes will be typeset. The slides may increase a counter, or they may be included as images. I could show more examples of code, but I think the general principle is clear now. I want to conclude with two special use cases that have been useful to me over the years. The first is, I've come to like XML as an input format. I know many people hate it with a passion, but I think it's a very, very readable and nice input format. If the input file is valid XML, it should compile in context, so you don't have to worry about forgetting some brace or whatever it is. In the beginning, this can be quite tedious, I agree. For everything you want to include in your presentation, you have to come up first with a proper XML representation, and you have to find a way to process this XML in context. And if something goes wrong, which never happens, of course, but in theory it might happen, there are always two layers to debug, the XML and the TeX. One disadvantage was that some things are really easier in TeX than in XML. For example, producing MetaPost graphics. In theory, you could come up with a way to write XML code that would then be translated to MetaPost code and typeset and displayed on your slides, but this would be really, really painful. Wouldn't it be wonderful, I thought, to have some way of writing MetaPost code or even any other TeX code and have it processed when context reads my XML file? This is something that hadn't been possible from the start, but Hans Hagen, of course, is always very gentle and nice with his users. So when I asked on the list, could you do this for me, he implemented it. We now have a command getBuffer that will process included TeX code, and here's how it works. Whenever my XML file is processed, context looks for a file called presentation buffers. This is what we do in lines 5 to 7. If presentation buffers exist, it inputs it into the stream, line 5 to 7. And this file contains, you may have guessed it, several buffers with TeX code that I just retrieved during my XML processing. I then define an XML element getBuffer, which takes this buffer, processes it as TeX, and includes the result in my slides. As an example, I'll show you a few lines of MetaPost code that I have used for this presentation today. It would be possible to do all this in XML, as I said, but I save myself lots of typing by just keeping this in a separate TeX file. Another area where this comes in pretty handy is something that I had to learn the hard way, verbatim code. When you process XML, cat codes have to be changed, and this appears to be problematic for including verbatim code. In particular, I had problems having XML code within the XML processed verbatim. So I cheat and include it in a TeX buffer, and this approach appears to work very well. Finally, a very easy way of simplifying processing these XML slides. Typing all these context, environment, mode calls all over again was getting pretty old after a while. So I wrote myself a little make file. It defines targets for the different output formats. It uses a variable day, which is then passed on as a context mode. It runs context once. It copies the resulting file to a new file that has this date as a name. It's nothing fancy, of course. It's just a way to save some typing at the terminal when I produce my slides. So this concludes my talk about processing XML with context in order to produce different output formats. I couldn't go into details here, as I said. I've been using this system for a number of years now, and it has become pretty complex, but it's also very easy to reuse part of an older lecture in a new one, because I just have to copy and paste individual parts, and they will always fit in because they're all valid XML. Thank you all for listening. I hope there has been some interest in using context to process XML. I think there's a bit of time left, so I will be happy to hear your comments and to answer your questions if there are any. Thank you.
I'd like to give you heads up for the numeric references for bibliography. That in humanities is not so frequent.
That's right.
As I know.
Because it's difficult to produce.
So are there any questions? I guess it was very interesting.
Sorry, I'm being interrupted from behind. So, so a lifetime ago, I wrote an XML parser in tech, but I don't use it. I mean, in my day job, I'm processing XML in multiple forms every day. It's what I agree with you that it's a lovely input format. But what I do, I use XSL, so I can have full, because I'm doing a lot. You have lots of different formats, but they're very linear. I mean, you don't suddenly want to print lecture 5 first. Mm-hmm. So I'm reorganizing things a lot more. So, I mean, did you consider using an XML tool such as XSL to generate context or tech, rather than using the tech? Mm-hmm. I mean, how much power do you lose in really reformatting the XML with a query language?
I don't think I lose any power. It's just it may be very tedious because you have to think about translating it. But in fact, anything you can do in context, you can do via XML. So there is no real loss in there. It's just, it may take a little bit of time, but as I know I will reuse this style year after year after year, it's worth the investment. So no, it's not something that I would consider, let's say, facilitating what I do. It wouldn't be easier once you have the process in place, of course.
Any other question? Yes.
In terms of debugging, do you have some kind of pre-processing flow, like an XML schema, or do you just typeset and hope for the best and maybe debug an error?
Well, as you see, I'm not very young anymore, so I use Emacs for XML writing, and Emacs... And Emacs has an XML mode which validates XML on the fly. So that's what I use. I don't have any pre-processing. I could use any number of instruments, but the XML is not very complex. Oh, the Emacs Vim war is going on. So it's not an incredibly complex XML. So Emacs is really sufficient for me. And as I said, if I see in the Emacs line a valid XML, I know that it should process.
Any other question? If not, oh yes.
It's not a question. I just want to see the slide with the workflow inside of it, the flow chart.
Let's see. This one?
Thank you, yes.
Sure. I mean, all the slides are already on the web page, so you can just download them and look at them. Beautiful, isn't it? That's what context does. Okay.
Okay, thank you. Any other question? So thank you again for the very nice talk.